Okay, so this is the Unit 3A handout that this lesson is going to cover. I'm going to apologize ahead of time for my voice. I don't know what's going on. I'm fighting off a cold, so my voice is a little raspy today. But let's work our way through, and we'll see if I last. All right. So the main topic in Unit 3 is parallel lines, but before we jump straight into parallel lines, there are some terms that you need to know. And so if you have two lines like H and K in this picture down here, and they're cut by another line, so this line T is called the transversal. And you can kind of think trans means, I think it means something related to travel, like transportation, or I don't know, translate would be to change, to move from one language to another. So it has something to do with moving. And I kind of think of the word traverse, which means to cross over, or at least I think that's what it means. So the transversal, or transversal crosses the other two lines. And what I did was I numbered all these angles down here, 1, 2, 3, 4, 5, 6, 7, 8. And different pairs of angles have different names. So the way that it works is you take one angle from here and one angle from here, and you match them up in certain ways, and you get different types of angles. So one thing is that if you look at 1, 3, 5, and 7, they're all on one side of the transversal. 2, 4, 6, 8 are on the other side of the transversal. So if I pick something, and the reason that I circled these angles is whenever I make a pair, I'm going to pick one angle from this chunk over here, 1, 2, 3, 4, and one angle from that chunk, 5, 6, 7, 8. So let me talk about some other terms first. Everything in between H and K, that's called the interior. So 3, 4, 5, and 6 are interior angles. Let me even highlight it a little bit better so that the 3, 4, 5, and 6 are covered up. Whereas on the outer parts here, this part 7, 8, and 1 and 2, those guys fall into the exterior. Okay? And if I were to pick something like angle 1 and angle 5, I'd say those are on the same side. But if I picked angle like 1 and angle 8, then I'd say they're on alternate sides. And that's based on which side of the transversal they fall on. So if I pick something from one side of the transversal and something from the other side of the transversal, then that would be called alternate angles. So there's one in particular called corresponding angles. And so if you look at where angle 1 is in relation to the other angles in this red circle, it's in the top left. And so that goes with angle 5 over here. So they're in corresponding locations. So I'm going to say angle 1 and angle 5 are a pair of corresponding angles. Similarly, like 2 is in the bottom left, 6 is in the bottom left. So angle 2 and angle 6 would be corresponding angles. And notice 3 and 7 are in the top right of each chunk, and angle 4 and angle 8 are in the bottom right of each chunk. So anytime they're in matching locations, then you call them corresponding, because they're corresponding locations. Okay, name a pair of alternate interior angles. So alternate means different sides of the transversal, and interior means between the two main lines. So like if I picked one interior angle, like 3, then I got to pick one from the other chunk, and it's got to be interior, so it's got to be 5 or 6, and it's got to be on the opposite side, the alternate side of the transversal. So it has to be 6, because 3 is above the transversal and 6 is below the transversal. And then if I picked 4 instead, so angle 4, that one would go with angle 5. Okay? For alternate interior. If I wanted to do alternate exterior, then let me start over here by picking one of the exterior angles on the left. So I'm going to pick angle 1. So if I need it to match it up with another exterior angle from the other chunk, it's got to be alternate, so it's going to be on the opposite side of the transversal. So 1's on top, 8's on the bottom. So it's 1 and 8. And similarly, I can go 2 and 7. Same side is a little bit easier. So same side would be same side of the transversal. So 1, 3, 5, and 7 are all on the same side. So if I said same side exterior, I'll pick 1 from the first chunk, and that'll go with 7 on the other chunk. Same side of the transversal and in the exterior of the two main lines. And similarly, I've got angle 2 and angle 8. Same side interior would be like angle 3 and angle 5, and angle 4 and angle 6. Okay? So that's these 5 terms corresponding alternate interior, alternate exterior, same side interior. They get used a ton in this unit and pretty much throughout the rest of the year. Okay, let's look at number 2. So there's a postulate that says if parallel lines are cut by a transversal, so if A and B are parallel and cut by transversal T, then corresponding angles are congruent. So it says that you can use this now as a reason in proofs. So the way that I abbreviate this one in a proof, I write parallel lines give you corresponding angles that are congruent. Okay? So let's try to use that fact somehow. All right, so the given here is A is parallel to B. So I'm going to write that down, given. And then what I'm going to start doing more of in these proofs is as we come across a step in the proof, I'm going to mark it in the diagram. So A is parallel to B. Remember, the way to mark parallel lines is with arrows. So if they each have one arrow, they're parallel to each other. Okay, so then the next step says 2 is congruent to 3. So notice I marked it in the picture. 2 and 3 are congruent. Well, the reason for that has nothing to do with parallel lines. That's just vertical angles are congruent. In step 3, it says 2 is congruent to 6. Okay, well here's 2, and here's 6. And if you notice, 6 is in the bottom right-hand side of this chunk, or on the right, it's the rightmost angle of that chunk. And 2 is the rightmost angle of this chunk. So angle 2 and angle 6 are corresponding angles in this picture. So over here, 2 is congruent to 6. That's where we get to use the fact we already have parallel lines. So we can say that the parallel lines in step 1 give us the corresponding angles that are congruent in step 3. Okay, so the goal is to get 3 is congruent to 6, so we know that has to go here. Well, I know 2 is the same as 3, and 2 is the same as 6, so I'm just going to replace that 2 with the 3 and end up with this line, right? So that is either substitution, or if you prefer substitution, you can also call it the transitive property. Transitive means if A equals B and B equals C, then A equals C. So if 3 equals 2 and 2 equals 6, then 3 equals 6. All right, so let's see what we just proved in number 3 here. Number 2 says we started out with parallel lines, and then we got that 3 and 6 were congruent. So let me erase everything here and just mark the given and the proof. The given is we started with parallel lines. So that means it's going to start, and the hint is it's similar to the italicized sentence up here. So if parallel lines are cut by a transversal, and then we determine 3 and 6 are congruent. So here's 3, here's 6. If you try to figure out what kind of angles 3 and 6 are, well, they're on alternate sides of the transversal, so they're alternate. And they're in between A and B, so they're interior angles. And we showed that they're congruent to each other. So now this statement right here, we can use in a proof as well if we ever needed to. So what I'm going to write here is the way that I abbreviate this one in a proof. Parallel lines give you alternate interior angles that are congruent. Okay? By the way, a nice way of determining where alternate interior angles are, because they come up a ton in this in general, is if you can make a Z shape. Right? If you can make a Z shape, the angles of the Z are going to be alternate interior angles. And if the top of the Z and the bottom of the Z are parallel, well, now you know that they're going to be congruent angles because the parallel lines give you congruent alternate interior angles. Okay? Okay, so let's go on. So in 4 here, in the diagram below, line A is parallel to line B. Let me choose a brighter color. Let's do red. Excuse me. Hold on one second. Let me get a sip. Okay. That's a little better. All right. So name all the angles congruent to angle 1. Okay, well, I know 1 and 4 have to be the same because they're vertical angles. So angle 1 is definitely congruent to angle 4. Well, I know angle 4 now. I can make this kind of backward Z here. Whoops. I don't know what happened there. Let me use a different color. So you see that Z? Well, it's a backward Z and it's stretched out, but you can still kind of think of it like a Z shape. Well, I know that the top and bottom of the Z are parallel, and so the angle 4 and angle 5 are going to be congruent alternate interior angles. So now I'm going to say 4 and 5 are congruent. By the way, you also could have done it because if you look at 1, it's in the top chunk of these 4 angles, and 5's in the top chunk of those 4 angles, and since the lines are parallel, angle 1 and 5 have to be congruent because they're corresponding angles. So that's another way to get that 5 is the same as 1. Well, similarly, you can either do vertical angles are congruent for 5 and 8, or you can say, well, look at 4, that corresponds with angle 8, and since the lines are parallel, I know that that has to match up too. Okay? So let me get rid of all this for a second. Put the parallel back. Okay, name all the angles congruent to 2. Well, we know 2 has to go with 3. And if I look at what corresponds to 2, that would be 6. And since the lines are parallel lines give me corresponding angles that are congruent. And then either you could say 6 and 7 are the same because of vertical angles, or you could say 3 and 7 are the same because, let's see, because they're corresponding angles. So there we go. Okay, so what can you say if you took any of the angles from part A and added it to any of the angles from part B? Right? So if you take any angle from part A and you add it to any angle from B, what do you get? Well, let's look. Let's try 1 and 2. Right? Here's 1, here's 2. Well, if you put those two together, you get a straight angle. So according to the angle addition postulate, that'd be 180 degrees. And since 2 is the same as 3, is the same as 6, is the same as 7, I could do the same thing with just 1 and 7, right? Here, I'll kind of do this. All of these guys were the same, and all of these guys were the same. So anything with 1 curve plus anything with 2 curves is going to be 180 degrees. Okay, that leads us into number 5. So some of these we've already done. if you have a parallel line cut by a transversal, by the way, the terms we're coming up with here are either congruent or supplementary. So if a transversal cuts parallel lines, we know that corresponding angles are already congruent. So I'll write congruent here. And in a proof, the abbreviation would be parallel lines, arrow, corresponding angles, congruent, like that. We know that alternate interior angles, we already did in number 3. Those would be congruent, like 4 and 5, or like 3 and 6. So in a proof, this is how it would appear. Alternate exterior angles. So we need exterior angles. So remember, exterior is on the outer parts of the two main lines. Right? So in this case, if I pick like angle 1, then I need something that's alternate. So on the opposite side of the transversal, like angle 8, right? And we know that 1 and 8 are congruent. Okay, if I wanted to do same side interior, then I need to pick 2 angles that are on the interior and on the same side of T. So like angle 5 and angle 3. Now notice angle 5 comes from the first group, angle 3 comes from the second group. So if I add them, I get 180, which means they're supplementary. So I'm just going to abbreviate that sup over here. Sup. Parallel lines give you SS's same side interior angles that are supplementary. Okay, and if we did same side exterior angles, well, I'll pick one from here like angle 7, and then I pick something on the same side over here, but on the exterior as well, like angle 1. So 7 and 1. Well, 7 is down here, 1 is up there. Anything from A plus anything from B is 180, supplementary. Okay, so again, these 5 things right here are going to be incredibly important for this unit because we're going to use them all the time. Now the nice thing is, there are actually 5 more reasons that get used all the time in this chapter, but they're exactly the same thing as these 5 up here in the previous problem, except that they're the converses. So if I write down all the converses, those are all things we can use in a proof. So like corresponding angles that are congruent give you parallel lines. So it turns out, notice here, if you know that corresponding angles are congruent, then you can show that lines are parallel. So in a proof, you end up like let's say I had something that looks like this. Let's say I showed that this angle here, angle 1, is the same as angle 2. Well, notice they're corresponding angles. I don't know anything about like my 2 lines, let's say A and B. Let's say I don't know that they're parallel yet, but I do know that angle 1 and angle 2 are congruent for whatever reason. Well, then my next line could be A is parallel to B because, well, I knew that the corresponding angles were congruent, so those give me parallel lines. So I can do that with all of these. Alternate interior angles that are congruent will give you parallel lines. Alternate exterior angles that are congruent give you parallel lines. And then there are the 2 more same side interior angles that are supplementary. Oh, let me shrink that. Give you parallel lines. And same side exterior angles that are supplementary give you parallel lines. Oh, my voice. Hold on. Okay. All right. All right, so in number 7, this one says, suppose you know 1 is congruent to 3, and 4 over here is congruent to 6. That says that there's enough information there to figure out that PQ is parallel to RS. So let's figure out why. Okay, well, 1's congruent to 3. I know 3 and 4 are the same because they're vertical angles. So really anywhere that there's 1 curve or 2 curves, they're all equal. So 1 equals 3, 3 equals 4, 4 equals 6. So 1 equals 6. If you look at 1 and 6 and the lines that form them, there's one line that forms 1. Here's the next line that forms 1, which also helps form 6. And there's the last line. Well, notice that's a Z shape. These two angles are the same. So the Z shape goes with alternate interior angles. And I know they're congruent, so I'm going to get parallel lines. So let's try doing this in a proof. Now I'm going to start with this. 1 is congruent to 3. That's given. Step 2, notice 1 and 3 are the same. Well, 3 and 4 are the same, right? So angle 3 goes with angle 4, right? That's not given. That's vertical angles are congruent. And 4 I know goes with 6 because that's given. Well, before I can just say that the lines are parallel, I need to specifically state which alternate interior angles I'm using. So that's 1 and 6. So first I have to say angle 1 is congruent to angle 6. Now the reason for that is anywhere that a 3 appears, I can replace it with a 1. So I'm going to plug in this 1 where that 3 is. Anywhere that a 4 appears, I can replace it with a 6. So I'm going to replace that 4 with a 6. And then I end up with 1 is congruent to 6, which is this line. That's really substitution. Whoop. Substitution. Or transitive. Okay, well, 1 and 6 are the alternate interior angles. If I move this over, you can see that a little more obviously, right? There's the Z shape. This was 1, this was 6. So I can now say, if I put this back, I can say that the lines on the outer parts of the Z are going to be parallel. So I'm going to say PQ is parallel to RS because I had alternate interior angles that were congruent in step 4, and they gave me these parallel lines. Okay? So we got a couple more problems here. What's the quadratic formula? Okay, the quadratic formula, if you remember it, is x equals, and I like to use capital letters just because they're easier for me to think about, but it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And you might have learned various songs for it. At some point in class, if you want, I'll teach you the song that I made up for it. There's one that goes to Pop Goes the Weasel, and I find that students never remember it because it doesn't rhyme very evenly. So I made one up because I was a preschool teacher, and that one rhymes, and it goes to Twinkle Twinkle. So if you want, at some point, I'll share that with you. Now, when can you use the quadratic formula? So this one's the quadratic formula right here, the x equals thing. You can use the quadratic formula when you have an equation in the form ax squared plus bx plus c equals 0. Okay, now it's super important that you realize the thing has to equal 0. If it doesn't equal 0, you're not going to get x out of this thing. You're going to get something else. You might call it x, but you'd be wrong. Now, note also there's a plus and a minus, right? So you have to do those two things separately when you're calculating them, and you actually get two answers. So note, the quadratic formula gives two answers, two solutions for x. Now, if this was just a pure algebra class, you put both solutions in a box and you're done. But since it's a geometry class, oftentimes the x represents an angle or something you plug into an angle or into a side, and you can't have negative angles or negative sides. So you'll need to check each answer with the original info to see if they make sense, to see if it makes sense. Okay, so number 9 is our last problem, and go figure, you have a y squared plus 43y. That should give you a hint that you might need the quadratic formula. Okay, so let's work our way through this. Now, we have to solve for x, we have to solve for y, and we need angle b. So let's see what we can do. Now notice here, the top and bottom are parallel. Okay. So here's what I'm going to do. I'm going to extend this line here and then draw in my parallels. And I'm going to ignore the other part of the picture. Whoops, sorry about that. And this is 4x. I'm just going to write it right on top. And this is 14x. And then what I can do with this is move that over to the side. Now if you look at that, the 14x and the 4x, they're on the same side of this transversal, and they're interior. So I know that parallel lines give me same side interior angles that are either congruent or supplementary. And if you come up here, the same side ones are always supplementary. So I know that these two guys are going to be supplementary. So to solve this, I'm going to say, well, 14x plus 4x has to be 180. Well, that's 18x equals 180. So x is going to be 10. And then we're done. You can plug it back in. That's going to be 140 degrees. That's going to be 40 degrees, and you're done. Okay? Now the y's are going to be more of a pain. So let's do this. I'm going to extend these lines so that it's a little more obvious. This is 90. This is y squared plus 43y degrees. And then let me move it down so it's easier to see. Okay, and these lines were parallel. Well, notice they're on the same side of the transversal, and they're in the interior here, right? Whoop, I lost my transversal. So that means that they have to be supplementary. So y squared plus 43y plus 90 has to equal 180. Well, notice I've got a y squared, a y, and some units. If I make it equal 0, then I can use the quadratic formula. The only difference is that this would be a y instead of an x now, right? Y squared, ay squared plus ay plus c, by plus c equals 0 is what I want. So let's get this to equal 0 by subtracting 180 from both sides. And if I do that, I get minus 90. So now I've got a equals 1, because there's a 1 essentially in front of the y squared. B equals 43, and c equals negative 90. So now I'm going to plug it into the quadratic formula, which says I need negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you can do this by hand if you want, but notice you're going to have to square 43 and then subtract 4 times 1 times negative 90. So what I would recommend is using the calculator. So here's the calculator. I'm going to turn it on. Clear that. Now I'm going to show you a trick. There's a way to just write this in the calculator and hit enter, and it'll just give you the answer right away. So what I want to do is, first I want to store A as 1, B as 43, and C as negative 90. So I'm going to hit 1, and then I'm going to hit this button down here that says store. And then if I hit alpha A, notice the green A right there, and hit enter, now it's stored as 1. So anytime I hit A, like if I did A plus A, it'll say 2, right? So A is 1. I want to do 43 and store it as b. Okay, and I want to do negative 90. Make sure you hit the negative, not the minus, and store it as c. Now what I want to do is type this in. Now, the calculator can only do a plus or a minus one at a time. It can't do plus or minus and give you two answers all at the same time. So let's do the plus version first. So if you remember, if I go alpha f1, I can get that fraction. So I'm going to do negative, whoop, I must have hit something by accident. There we go. So negative b plus the square root of b, and then this button squared, minus 4ac all over 2a. And now that I've got a, b, and c stored, there you go. So one of the answers we get is y equals 2. Now there's also the minus version down here. So if I come back up here and hit enter, it'll cut and paste it, and then I can just scroll over to the plus and switch it to a minus and hit enter. Negative 45. So the other answer would be y equals negative 45. Now the mistake a lot of students think is, that's got to be wrong. Well, let's check, right? So if I plug in 2 up here, I get 2 squared plus 43 times 2. 2 squared plus 43 times 2 ends up being 90. And that's good. That makes sense for that angle. It should be 90. Well, this one, excuse me. This one, if I plug it in, I do negative 45 squared. You got to put the negative 45 in parentheses, by the way, plus 43 times negative 45. And it turns out if you plug that into your calculator, negative 45 squared plus 43 times negative 45, you still get positive 90. So that actually means both of these answers work. So you actually get two different y values for this problem, and they both give you an angle of 90 degrees right there, which is okay. That's fine. If you get two answers that work, you get two answers that work. The last question was, what's angle B? So we got x, we got y. What's angle B? Well, we already figured out. That's got to be 90 degrees. Okay, so that's the end of this lesson. Hope that helps.